Alright, so in this video we're going to review the latest half-term assessment on the mechanics topics, looking at both energy and momentum. So let's get started straight away. So we've got a graph showing the force acting on a rocket and how it varies with time. Which one of the following is represented by the area under the graph? So the area under a force time graph is an impulse, which is a change in momentum. So this is just one of those questions you just have to know. There's not much of physics, which is just remember quotes type stuff, but this is an example of one of them. Okay. So we've got a railway track of mass 8,000 kilograms traveling at 2.5 meters per second. It collides with a stationary truck of 12 tons, and they move off at the same velocity after the collision. Calculate the change in momentum of the 8,000 kilogram truck. So the key thing is going to be working out the velocity of the combined object after, and then from that we can calculate the answer. So let's set up our conservation of momentum expression. So 8,000 times 2.5 is the total momentum before, and the combined masses is 20,000 times the velocity, which gives us a velocity. Let's just calculate that. So 8,000 times 2.5, 20,000. So it's just going to be 1 meters per second. So change in momentum is going to be the final momentum minus the initial, which is going to be the mass, which is 8,000. 1 minus 2.5, so 1 minus 2.5 times 8,000 gives you minus 12,000 newton seconds. So the change in momentum is going to be 12,000, which is option B there. Okay, let's move on. Okay, so we've got a firework rocket fired vertically in the air and it explodes at its highest point. What are the changes to the total kinetic energy and the total momentum of the rocket as a result of the explosion? So the key thing is, so before the explosion, if you reach it's fired vertically and it reaches its top, its velocity is 0. So before, the kinetic energy and the momentum are both equal to 0. Now, an explosion is a scenario in which the total momentum is 0 before and after, so we know the total momentum isn't going to change, and there's no external force acting, so there's nothing that could cause it. So we know it's not these two here, because no external force has been applied, so there can't be a change in total momentum. However, once it explodes, what we're going to do is take fuel type energy, so gunpowder or whatever it is, and transfer that into kinetic energy, and we're going to increase the kinetic energy of the rocket. So what we're going to get is option C there. Alright, so let's move down. An object is accelerated from rest by a constant force for a time t. Which graph represents the variation of time, the kinetic energy, and the momentum? So let's use Newton's second law. Which we have like this. So what this says is the change in momentum, the rate of change of momentum is direct proportional to the force. So if you have constant force, the rate of change of momentum with time will also be a constant. So that would be the gradient of the momentum versus time graph. So that means the momentum versus time graph has to be a straight line. So we can get rid of this. So using the fact force is constant, we get that the rate of change of momentum with time is constant, and this is the gradient of a momentum time graph. So we can get rid of those two options there. We can also get force is equal to mass times acceleration, due to mass, change in velocity, change in time. So if your force is constant and your mass is constant, that means your rate of change of velocity with time is going to be a constant. So if we just sketch a velocity time graph, it would look like that. But remember that kinetic energy is calculated by squaring velocity. So what that's going to look like is a quadratic graph. So up like this. So that's going to be option A there. Okay. Right, so for this next one, we've got a velocity time graph, and we want to see which graph below represents how a resultant force on the car varies during the same time. So if we look at some key features, we can see at the end the gradient is 0 because it's a horizontal line, and the gradient of a velocity time graph is the acceleration. So we can see that the acceleration and therefore resultant force is going to be 0 at the end. So we can already eliminate option C because it doesn't show that. If we look in here, we can see the gradient is increasing, which means the acceleration is increasing, which means that the resultant force must be increasing to start with. So we can see that we can get rid of this one because it shows, and this one, because they both show decreasing force initially, which leaves us with A as the correct answer. So let's just double check that. So towards the end, we can see the gradient is decreasing, so acceleration is decreasing, so force is decreasing towards 0, so that matches with the graph as well. Alright, so we've got two trolleys, one's travelling at 4 meters per second, they're identical and they collide, and we've got an elastic collision, which means total kinetic energy is conserved before and after. So which one of the following statements is correct following the collision? So collisions are dealt with by conservation of momentum, so let's just calculate the momentum before, so it's going to be 4 times 2, so that's going to be plus 8.0 Newton seconds. So the total momentum is going to have to be that value throughout. So if we look at option A, so T1 becomes at rest and T2 moves at 4 meters per second. So that would have a total momentum of 8 Newton seconds. So that statement there is definitely possible. T1 will rebound from T2 at 4 meters per second. That would have a total momentum of minus 8 Newton seconds because it's in the opposite direction. That doesn't work. Both of them would move at 2.8. The total momentum then would be 2 times 2 times 2.8, so that's 5.6 times 2, which is 11.2 Newton seconds, so it can't be that one. Both move at 1.4, 2 times 1.4, 5.6 Newton seconds, again plus, can't be that one, so it's going to be option A as we saw earlier. Okay, so a car exerts a driving force of 500 newtons when travelling at a constant speed on a level track. What is the work done in 5 minutes? So the first thing, work done is going to be power times time, and power is force times velocity, so work done is force times velocity times time. That's going to be 500 times by 72 kilometers per hour, but in meters per second, times by the time in seconds. And when we work through that, let's just calculate that now. That ends up being 3.0 times 10 to the 6 joules. So that's option A again. So we've got another A. Okay, so let's move next. An electric motor of input power 100 watts raises a mass of 10 kilograms vertically at a steady speed of 0.5 meters per second. What is the efficiency? So efficiency is going to be useful power divided by total power times by 100%. So we need to work out what useful is. So we know if it's going at a steady speed of 0.5 meters per second vertically, it's going to go half a meter every second. So it's going to gain half a meter of times m times g of potential energy per second. So that's going to be 10 times 9.81 times 0.5, which is 49.05. So we calculated the GPE energy it gains per second, and energy per second is power. So then we can plug that into this calculation up here. So 49.05 divided by the input power, which was 100, times 100%. So you can see that's going to be 49, so it's roughly 50% there. Right, so we've got a ball bearing X of mass 2m projected vertically upwards with speed u. Ball bearing Y of mass m projected 30 degrees to the horizontal. So 30 degrees to the horizontal with 2u. Air resistance is negligible. Which of the statements is correct? So the horizontal component of Y's velocity is u. So the velocity of horizontal of y is going to be given by 2u cosine 30, which is 2u root 3 over 2, so it's just root 3u. So that's not correct. Maximum height reached by y is half that reached by x. Well, we're not going to know that until we know the vertical components of velocity. That's what dictates the GPE it can gain, because it's only the velocity in the vertical direction that controls that. So let's work out the velocity in the vertical direction of y is going to be 2u sine 30, which is 2u times a half, which is u. So we can see that they both have the same vertical component of velocity. The only difference is that this one also has a component in the horizontal direction. So if they have the same vertical velocity, they're going to take exactly the same time to get back to the ground, and they'd have the same maximum height. So we can get rid of that one, because if they have the same vertical velocity, they get to the same maximum height by applying conservation of energy. And if they have the same vertical velocity, they'd reach the ground at the same time as well. So that's going to be option C. Okay, so we've got a lift with mass 500 kilograms, accelerating at 2 meters per second squared. G is 10. Calculate the tension. So the first, let's calculate the resultant force, which is 500 times 2, which is equal to 1,000 newtons. So let's have a look at what the resultant force is equal to. So we know that T minus mg is equal to 1,000, because that's the resultant force would be the difference between T and mg. So T is going to be 1,000 plus 500 times 10, 6,000 newtons there. So option D. A lot of people, when I was marking this, went for option A because they calculated the resultant force, not the tension. Be careful with these questions.